Hey guys, here's your video for Unit 7.1 and 7.2 activity. So our 7.1, we're going over symmetry. So on here, we're going to determine whether the figures have line symmetry. And remember, line symmetry is that we can fold it and the points match up. So 1 is a yes, 2 is a yes, 3 is a yes. I didn't think that these circles would line up, but apparently they do. 4 is a no, 5 is a yes, and 6 is a yes. And on the yeses, you can see where I've marked their lines of symmetry. 7 through 12, we're going to determine whether the figures have point symmetry. Remember, point symmetry is if we flip it upside down, just like it is, does it look the same? 7 is a no, 8 is a yes, 9 is a yes, 10 is a yes, 11 is no, and 12 is no. All right, so 13 through 18, we are going to determine whether figures have rotational symmetry. We're going to choose yes or no, and if yes, we're going to state the order. So 13, the star, it's a yes, and it has an order of 5 because we can turn it 5 times before this original top point here comes all the way around to the top again, and the star looks the same. 14, the heart, no, because it has to make a full turn before it is looks the same again. So on this one, it's a yes, and it has an order of 10 because we can turn this 10 times before this original point comes back to the top and it looks the same. 16 is yes with an order of 4. 17 is a yes with an order of 2. And I thought that this one would be a no originally, but then if you think about it, if this is our starting top side, if we turn it 180 degrees, it's going to be at the bottom and going to look the same. So I was incorrect on that one. This one is a yes, and it's an order of 2, and 18 is a no. On this bottom part, we're looking at these capital letters, and we're sorting them into the Venn diagram by if they have a vertical line of symmetry, so vertical, or a horizontal line of symmetry. If they have both, they go here in the middle. So on your vertical line of symmetry side, you should have A, M, Y, U, T, V, and W. On your horizontal line of symmetry, you should have B, D, C, E, and K. And in the middle here, we have H, I, O, and X. So there is your 7.1. So 7.2, I'm not going to plot the points, but here is what your chart should be filled out as. If we dilate by half, we take our coordinates and we multiply them all by 0.5. If we dilate by 2, we take our coordinates and we multiply them by 2. Remember, if we dilate anything by 1, we take our 1 and multiply all of our coordinates, and we come up with the same coordinates. So anything dilated by 1 is going to be the same as the pre-image. All right. So find the image coordinates of the triangle with original pre-image coordinates of M, N, and P. We're going to dilate that to a scale factor of 3. So if our scale factor is 3, we just go and multiply each of our coordinates by 3. So for M, 0 times 3 is 0, and 4 times 3 is 12. This is how we got M. For N, we had 4, 2, so we're going to multiply 4 times 2 and 2 times 2. Or, I'm sorry, 3. And so this would be 4 times 3 is 12, and 2 times 3 is 6. There we go. And then on P, we have 2 comma negative 2, so we're just going to multiply each of those coordinates by 3, and we get 6 comma negative 6. So on number 3, it's telling us that we have a pre-image and an image coordinate of a dilated polygon. Under what scale factor has the polygon been dilated? Well, first off, we need to figure out which one of these points is our original point. Well, we can tell that easily because this point here has this little prime up here. So we know that that means that's our ending image. Let's look at our coordinates. We have 8 comma negative 12 and 2 comma negative 3. Does it get bigger or smaller? Do these numbers get bigger or smaller when we go from our pre-image to our image? Well, they get smaller. So if it gets smaller, we know it's going to be a reduction. And how do we get from 8 to 12? Or I'm sorry, 8 to 2. 8 and 12 to 3. Well, we divide by 4. So we're going to divide by 4. And if we're going to divide by 4, it's going to be 1/4. Number 4. The image of point M after a dilation of 3 is 6 comma 15. So what's the original location of the point? Well, if we had an original point, we know that if our scale factor is 3, we're going to multiply that number by 3 to get this new point here. So if we multiply to get here, what do we do to get back? We divide. So 6 divided by 3 is 2, and 15 divided by 3 is 5. So that's where we get our answer of 2 comma 5. Number 5, we find the image coordinates. Sorry, alarm. We find the image coordinates of a triangle with coordinates A, B, and C. And we're going to dilate them by a scale factor of 1.5. So here we're going to take all of these coordinates, each one separately, and multiply by 1.5. And these are your new coordinates here. All right, 6. It says if the dilation of point K, which was at negative 2 comma 4, equals K prime of 1 comma negative 2, what is the scale factor used in this dilation? Well, we know that K, this K here, is our original, and this K prime is our ending. Excuse me. So how do we get from negative 2 to 1? How do we get from 4 to negative 2? Well, if we have a negative and we're getting to a positive, we know that we have to multiply by a negative. If we have a positive and we're getting to a negative, we have to multiply by a negative. So this is going to be a negative. And what is 1 from 2? Well, it's half. What is 2 from 4? It's half. So this is where we get our negative 1/2. Number 7 is Mary performs a dilation with a scale factor of 1/2 on a quadrilateral as shown below. Did Mary perform the dilation correctly? If not, find her errors. So we're looking here, and when we go from, these are our pre-image, and this bottom row is our image. So did she multiply correctly? Well, half of 2 are 1. Half of 6 is 3. Oh, half of 2 is 1. So this one is incorrect. Is half of 6 3? Correct. Half of 4 is 2. On H, half of 2 is 1, and half of 4 is not 8. So that one's incorrect too. So points F and H she did incorrectly. 8. We found the scale factor used to dilate the rectangles below. What was the dilation? Was it a dilation or an enlargement? So on here, Remember, we have in our notes, we have different ways of finding the scale factor. Well, on this one, where it's not giving us our points, our coordinates, but it's giving us our side lengths. So here we're going to choose our sides that we're going to work with here, and we're going to look and see what we have. So if we have our notes, and it tells us that we go in and we need to first decide which one of these is our original. Well, our original is this one because our points on our larger rectangle have our prime. So we know we went from this triangle to this triangle. And this triangle, our original, has a side of 5, or this side's 5, and this side's 15. So we can either look at our 5 and 15 or our 3 and our 9. Let's look at 5 and 15. Those are really easy to divide. So what we do is we go in, and according to our note, we put our image side length over our original side length. So our image side length is 15, and we put that over our original side length, is 5. And so this is where that is a fraction, but we can simplify that fraction. 15 over 5 if we divide 15 by 5, we get 3. So 3 is our scale factor. So we see where we got this. We have our image side length over our original side length, 15 over 5. Let's pretend like we can make a good fraction here. And if we solve that out, we get a scale factor of 3. Number 9, the pre-image and image coordinate of a dilated polygon are shown. Under what scale factor has the polygon been dilated? Well, we have to decide which one's our pre-image and which one's our image or our ending image. Well, it's marked right here. We have our prime. So our prime here tells us that's our ending image. So now let's look at our coordinates. We have 2, -3 and 3, -4.5. So what do we have to do to 2 to get it to 3? Well, we multiply it by 1.5. Same thing with -3 to get to -4.5. We multiply by -4.5. Do these numbers get bigger from the original image to the image? Yes, they do. So it is an enlargement. All right, guys, I hope that you have gotten these answers in, and if you have any questions, let me know.